And remember I told you the first part of chapter 3, what we do is we get into addition, subtraction, and multiplication of those polynomials. Well, the last thing that we talked about was the multiplication of those polynomials. And today what we're going to do is we're going to start factoring, which is the opposite of multiplication. So last week what we did is we took like two binomials and we multiplied them together, pulling them out. Well, now what we're going to do is we're going to start with a polynomial, and we're going to factor it into a multiplication problem. So we want our answer now to be a multiplication problem. Basically, we're going to undo what we learned how to do last week. Okay? Now, when we talk about factoring, there are a few things that you need to know. When you factor, the first thing you're going to look for is the greatest common factor. That's going to be the first thing you're always going to look for, is what's in common with all of the terms. For example, if you have a trinomial, if there is a greatest common factor, it has to be in common with all three terms. If you have a binomial, it has to be in common with both terms, and so on. Now, greatest common factor will be the first thing you look at. So next week when you get your test and you see the directions that the directions say factor first, look for a greatest common factor. That's going to be the first one. Okay? The second thing is, and this only, factor by grouping only refers to 4 terms. Okay? So if you have a 4-term polynomial and it says factor, you only have one of two options. One, it has the greatest common factor, or two, it could possibly have a greatest common factor and it will factor by grouping. Okay? So, factor by grouping, if you see 4 terms, the first thing you're going to look for is the greatest common factor. Then, if it doesn't have a greatest common factor, or even if it does, see if you can factor it by grouping. Okay, so that's 4 terms. The only time you're going to do this is if you have 4 terms. The next thing we have is trinomials. And we have 2 options. A, your leading coefficient is 1, and B, your leading coefficient is not 1, and we'll factor them differently. And then the last thing you have is your patterns. Okay? So, a lot of people think factoring is hard, but I think that comes from the fact that when you look at a polynomial, you're overwhelmed as to, well, what do I do with it? When you see the directions that say factor, and you see a polynomial, go through those processes. If it's a binomial, either 1, it's a pattern, or 2, it's the greatest common factor. Possibly both. If it's a trinomial, greatest common factor, pattern, or leading coefficient 1 or not 1. If it's a quadrinomial, 4 terms, greatest common factor, and grouping. Okay? So always go through those steps when you come to factoring. Alright, so we're going to take these in order. The first thing we're going to look at is the greatest common factor. What you're going to do, like for example in this trinomial, what you're going to do is you're going to look for all 3 terms and see if there's anything in common. So what we're going to do is we're going to divide out anything in common. So what do you notice that's in common? 2x. We can divide a 2 out of each one of these. And we can also divide an x out of each one of these. Now, some people say, well, why can't we divide 3 x's out? Well, because the second term doesn't have 3 x's to give up. Nor does that last term. That last term doesn't have 3 x's to give up. So that's what you're looking for. What's the most that all of them can give up? And in this case, it's just the 2x. All right, so remember we're going to turn it into a multiplication problem. So when you see factoring, you know that parentheses are going to be involved. And don't forget to take your greatest common factor out front. Okay? So make sure you take your greatest common factor out front. It is part of your answer, so make sure you write it down. A lot of people, you'll divide out that greatest common factor and then you won't put it in your answer. It has to go in your answer. So if we divide a 2x out front, let's look at each term and see what we have left over. If I divide, and we did this last week, 2x to the third by 2x, what do I get? 1x squared, because the 2 divided by 2 goes to 1. X to the third divided by x to the first, remember you subtract those exponents, it's going to give you x to the second. Okay, so let's go to the next term. 4x squared divided by 2x, what are you going to get? 2x. And 6x divided by 2x, just a 3. And for right now, you're done. Okay? Now, the complication is later on when we learn how to do trinomials, the question is, well, can I go ahead and factor this trinomial? For those of you who have a little bit of knowledge about factoring, can you factor that trinomial? Ask yourself, is there anything I can multiply together to get 3 and add together to get 2? What are the factors of 3? 1 and 3. If you add those together, do you get 2? 1 plus 3 is 4, so that won't factor. Well, the signs tell me I have to use both positive. So that will not factor. That's as far as you can go. All right. The next one we're going to talk about is factor by grouping. Remember I told you to factor by grouping, you have to have 4 terms. So the first thing we're always going to look for is anything in common. And ask yourself, do all 4 terms have anything in common? All 4 of them. No. 2 of them have an A in common, but not all 4 of them. 2 of them have a 3 in common, but not all 4 of them. 2 of them have a C in common, but not all 4 of them. And 2 of them have a B in common, but not all 4 of them. So all 4 terms do not have anything in common. Okay? So, nothing's in common, so we'll start factor by grouping. And what we're going to do is we're going to group the first 2 together and group the last 2 together. Now, when you do this, it is a process. Okay? So you have to memorize the process. And again, that's the problem with factoring. A lot of people don't like to memorize math. Factoring is memorization. So if you get that in your brain, you have to memorize factoring just like you have to memorize all the cell structures in biology. It's memorization. Okay? So, look at this. The first step is to group the first 2 terms and the last 2 terms. Notice when I grouped these last 2 terms, I included the sign. That's very important. Make sure you include this middle sign with that second grouping. Don't leave it out. Okay? So right now, I have a multiplication problem, right? I have a binomial times a binomial. It's a multiplication problem. Well, what I'm going to do is I'm going to take these 2 groups and I'm going to factor out what's in common in each group. Okay? So in this first group, what's in common? An A. Positive A. So let's bring out a positive A. And I'm going to have B plus 3 left over. So in that second group, what's in common? A positive C. So bring out that plus C. And I have a B plus 3 left over. Again, remember how to factor out a common factor. Here we'll factor out an A, which means you're dividing each term by A. Here we're going to factor out a C, so we're going to divide each term by C. Okay, that's all you're doing, what we just did. Now, what do you notice? Do you notice that these 2 are identical? This should always happen. When you factor by grouping, the 2 groups that are left over must be identical. Same sign, same term, same everything. They must be identical. If they're not identical, don't take it for granted and say, well, I got to fix it and just erase. No. Figure out what happened here. If these two are not identical, then you factored something incorrectly out. Okay? So, if you know that you factored it out correctly and these are still not identical, then this is not factorable. Just erase and move on. Now, this is what I want you to understand at this point. I went from a multiplication, technically, a multiplication problem to an addition problem. Do you see that? So if you see that this is an addition problem, how many terms are we adding together? 2. 1, 2. Okay, let's go back up here. In this group, how many terms am I adding together? 2. What's in common with the 2 terms that I'm adding together? An A, and we factored it out, right? Let's take that question here. You just told me that I'm adding 2 terms together, right? What's in common between these 2 terms? The B plus 3 group. That's what's in common. So what we're going to do, just like what we did here, we factored an A out. Out of these 2 terms, we're going to factor out what's in common. And you just told me what was in common. We're going to factor out the group B plus 3. So if I factor out a B plus 3, what's left over? And you're done. Because think about it. If I have an addition problem and I factor out what's in common, it turns it into a multiplication problem, right? So let's go back. I have an addition problem. I'm going to factor out what's in common, and it turns it into a multiplication problem. So every time you factor, it turns into a multiplication problem. Okay? Try it. Alright, so on the first one, we discovered that we have a 15 in common, because 15 will come out of 15 and 45. We have an x to the 4th in common, and we have a y to the 2nd in common. So if we divide each one of these by 15 x to the 4th, y to the 2nd, again, what I was saying is 15x to the 4th, y to the 2nd divided by itself is 1. If you start with a binomial, you have to have a binomial in your answer, okay? Make sure you bring down your greatest common factor out front. Don't leave it behind. It's got to be in your answer. And then if we do negative 45 divided by 15, we're going to get negative 3. X to the 5th divided by x to the 4th is just x. Y to the 4th divided by y to the 2nd is going to be y to the 2nd. Alright, on the right hand side, if you group like this, you'll notice in the first group, there's not really any term in common aside from 1, which is okay. But if you factor a 1 out, you're certainly not going to get identical binomials. So, you should try to rearrange them. I think most people group the 2's together, possibly, and then group the 3's together, which is fine. Okay, so now out of the first group, we have a 2a in common. And if I factor a 2a out, I'm going to have a minus b. On the right-hand side, if I factor a positive 3c out, I'm going to have negative b plus a. But if we write this in descending order, we'll have a minus b. So you'll see that they're the same. Okay. So now I can factor out an a minus b, and I would have 2a plus 3c left over. So, when you see four terms, if nothing's in common and it won't factor, before you just write it off and say not factorable, try rearranging them and see if it'll work that way. Okay? Alright, so let's talk about patterns. Do you remember last week when we had two binomials that looked like this? And I called it a sum and difference, and I told you to remember that pattern? Remember, if we full out a sum and difference, when you do the full method, the two middle terms cancel each other out. And what you get is the difference of two squares. So now we're going to go the other way. We're going to start with the difference of two squares, and it will always factor into. No questions about it. The difference of two squares will always factor into a sum and difference. Okay? So, here's your process. Remember, it's a process that you just have to memorize. First of all, know what it's called. Because if you know what it's called, it's easier for you to pick up. First word you see is difference. It has to be a minus sign in there. Has to be a minus sign in there. The second thing that you should pick up is two squares. You should have a minus sign in the middle of two things that you can take the square root of. What's the square root of 4? What's the square root of 25? What's the square root of x squared? X. Okay? Little hint. Your exponent for a square has to be even. If it's odd, you cannot take the square root of it. Alright? So, once you realize that you have the difference of two perfect squares, you're going to open up two sets of parentheses, put a plus in one, a minus in the other. Take the square root of the first term and put it up front of each group. Take the square root of the second term and put it in the second spot of each group. And you're done. Okay? So, once you realize that you have the difference of two squares, open up two sets of parentheses. Put a plus in one and a minus in the other. It is a process that you have to memorize. These patterns, you have to memorize it. There's no rhyme and reason to it. You just have to memorize it. Square root of 4x squared, you've already told me, is 2x. So it goes in the first spot of each group. Square root of 25 is 5. It goes in the second spot of each group. And you're done. The difference of two squares will always factor into a sum and difference. Always. Doesn't matter if the plus comes first and the minus comes second. No. If you wanted to put the minus sign here and the plus sign here, it's the same thing. When you pull it out, those middle two terms are going to cancel out. Notice the statement that's in red. I put it in red and start and everything else, so hopefully that you will remember this. If there's a plus sign in there, it is called prime. Anything that will not factor is called prime. So if you come across something that you cannot factor, the answer is prime. Won't factor. Alright, so we have the difference of two squares. All of these are the difference of two squares. So I'm telling you this, okay? I'm giving you a hint. All four of these problems are the difference of two squares. So if you know the process, then you can factor these. So let's take the first one, for example. This is the difference of two squares. How do I know? Well, first of all, I have a minus sign. What's the square root of x to the fourth?
X squared.
X squared. What's the square root of y to the fourth?
Y squared.
Y squared. So I just proved that is the difference of two squares. Once you realize you have the difference of two squares, you start your process. What's the first step in the process? Two set of parentheses, put a plus in one and a minus in the other. What's the next step? Take the square roots. Square root of x to the fourth, you've already told me, is x squared. That goes in the front two positions of each group. Square root of y to the fourth is y squared. That goes in the second position of each group. Now let me give you another hint. If your problem starts with exponents higher than 3, more likely than not it's going to factor again. So don't stop. This right here will factor again. And let me throw a word of caution to you, because you may want to put a star next to this so that when you study you won't do this. Watch. Number one mistake, when somebody factors the difference of two squares, and I'm telling you it will be on your test, so don't do this, is they factor x squared plus y into a sum and difference, and they factor x squared minus y squared into a sum and difference. What's the problem with that? The first one's prime. I just told you that. The first one is prime. Look, it's a plus sign in between two squares. That's not the difference of two squares. So it won't factor. That grouping will not factor again. So you just bring it down. It has to be part of your answer. But the second grouping is your pattern. That is the difference of two squares. So we'll do the process again. Open up two sets of parentheses. Put a plus in one, a minus in the other. And take the square root of each term. Square root of x squared is x. And the square root of y squared is y. Now you're done. So please don't factor the sum of two squares. It is prime. Okay? So let's go to the one on the top right. This is, watch guys, this is the difference of two squares. X plus 3 quantity squared is a perfect square. Because if I take the square root of it, I'm going to get x plus 3 right back. Watch this. When you take the square root, and we're going to hit this hard in chapter 5, so remember this for when we get there so it'll be a little bit easier on you. When you take the square root of a square, watch, the index here is 2. So this cancels this, and you're just left with the group, the binomial. Okay? So, a binomial square, when you take the square root of it, you just get the radicand. What's underneath the radical? Back. So, difference of two squares. Open up two sets of parentheses. Put a plus in one and a minus in the other. Same process. Once you realize that you have the difference of two squares, you do the exact same process. Open up two sets of parentheses. Put a plus in one and a minus in the other. What is the square root? See how many people were listening. What is the square root of x plus 3 quantity squared? It's just x plus 3. So that's going to go up front.
Isn't it a problem?
No. This is the same as you're thinking of that's prime. Big difference. Not to mention the fact when you pull that out, you're going to get x squared plus 6x plus 9, which is certainly not prime. It's another pattern. All right, and then the square root of y squared, and you're done. So we can take the square root of a binomial square. Okay? Now, bottom left. Let's see how many of us learned our lesson. When the directions say factor, what's the first thing you always want to look for? Anything in common? Throw you a word of caution. This problem, as is a pattern. It is the difference of two squares, right? Because what is the square root of 9x squared? 3x. And what's the square root of 36? 6. So that is the pattern. But watch what happens. Don't write this down because this is wrong. This is why you always look for a greatest common factor first. Watch this. If I do the pattern, again, don't write this down because it is wrong. If I do the pattern, I'm going to get a 3x plus 6 and a 3x minus 6. This is not factored completely. Can you tell me why? In each of these groups, there's a 3 in common. So I have to factor a 3 out. Watch. If I factor a 3 out, I'm going to get x plus 2. And x minus 2. And so you're thinking, well, that's grouping. No, it's not grouping because I still have a multiplication problem here. So where do you go from here? And I will tell you, that answer is correct. But how many of you would know what to do when you got here? How many of you would take this and get this answer and write it down on your answer blank? Probably 100% of you. You would stop right here. And you can't do that because it's not completely factored. Okay? So instead of doing this, do you remember the answer that I got? The answer is correct. The question is how many of you could get there. So instead of doing that, do your factoring process. Look for the common factor first. There's a 9 in common, yes? Take the 9 out. So you'll have x squared minus 4. Now look. X squared minus 4 is still the difference of 2 squares. So it'll go again. Bring your 9 down. It's got to be in your answer. Open up 2 sets of parentheses, plus in one, minus in the other. Square root of x squared is x, and the square root of 4 is 2. Is that the answer that I got a while ago? Yeah. So the answer was right. The question is how many of you could get there? All right. So always look for something in common first. All right, so let's go one step farther. Look here. Look at what you're looking at, okay? This is the difference of 2 squares. All right? Since I have the difference of 2 squares, I'm going to open up 2 sets of parentheses, put a plus in one and a minus in the other. Are you picking up on that process? When you realize you have the difference of 2 squares, just start the process. Open up 2 sets of parentheses, put a plus in one and a minus in the other. Now, the problem above, we took the square root of a binomial squared, right? So you know how to do this, yes? What is the square root of x minus 1 quantity squared? So that's going to go up front. What is the square root of x plus 4 quantity squared? So far, so good? That's hard to pick up on, so just kind of wrap your brain around it. Now, up here, there was no simplifying that we could do, right? There's no like terms that I can combine. Do you agree? Let's look right here. Go back to the 3.1. We talked about it last week. Look inside this grouping right here. We are adding 2 binomials. We did that in 3.1. How do you add 2 polynomials? You combine like terms. You just combine like terms. Look, x minus 1 plus x plus 4. Where are the like terms? X and x. What's x plus x? 2x. What's negative 1 plus 4? 3. Because, guys, what we're doing is what we did in 3.1. Watch. If I asked you to add x minus 1 and x plus 4. We did this the other day, remember? And all I told you to do was change the word form. And from here, we just combine like terms. You're doing the exact same thing. The exact same thing. Okay, so let's go to this group. What are we doing? We're subtracting. like terms. So what is x minus x? 0, they cancel out. What is negative 1 minus 4? And you're done. So just be aware, the difference of two squares can come in many, many shapes and sizes. Okay? Okay, let's talk about sum and difference. In your books on page 137, you'll see this pattern. Okay? Sum and difference of two cubes. Understand the difference. We already have a pattern called the difference of two squares. That has to be subtraction. I've already told you that. It has to be subtraction. But when we talk about cubes, it doesn't matter. It can be plus or minus. Okay? So, here's your pattern. When you factor the sum or difference of two cubes, it's going to factor into, always, it's going to factor into a binomial times a prime trinomial. It will not factor again, okay? Sum and difference of two cubes will factor into a binomial times a trinomial. So how do you get there? Well, first thing you're going to do is you're going to find the cube root. And again, we're going to talk about this in chapter 5, so don't lose this. You have to find the cube root of the two terms that you start off with. So, let's talk about the cube root of 8x to the third. What times what times what? What times itself 3 times will give you 8? 2. So the cube root of 8 is 2. What times itself 3 times will give you 125? 5. So the cube root of 125 is 5. Okay? So once I realize that I have two perfect cubes, I know it's the pattern. So what are you going to do? We're going to open up a binomial and a trinomial. Just kind of a guide. Call it a skeleton, and now we have to fill it in the skeleton. Look right here. If you're a right-brained person, do this. If you're a left-brained person, do this. It's completely and totally up to you. So, what are A and B? A and B are the cube roots that we just took. Okay? So, in this binomial right here, you're going to put A same sign B. A is the cube root of 8x to the third, which is 2x. Because x times x times x is x to the third. So A is 2x. Goes right here. Same sign. B is the cube root of 125y to the third. So the cube root of 125y to the third is 5y. So A, same sign, B. Follow it. A, same sign, B. Again, A is the cube root of 8x to the third, which is 2x. Same sign. B is the cube root of 125y to the third, which is 5y. Now, this is going to be hard for you, but this is what I want you to do. Forget about the original problem. Once you have your binomial, forget about this. It's gone. Don't go back. Okay? So we have A, same sign, B. Times is your parentheses. A squared. What is 2x squared? 2x times 2x. 4x squared. That goes here. 4x squared. Opposite sign. What is the opposite sign? Positive. Negative, so you have a minus sign. A times B. What is 2x times 5y? 10xy. That's your middle term for your trinomial. And then always plus B squared. What is 5y squared? 25y squared. That's your last term. Alright, one more time. You're going to have a squared, which is going to be 4x squared. Opposite sign, a times b, which is 10xy. Always plus b squared is going to be 25y squared. And you're done. Okay? Memorization. You have to memorize the process. Where is the process? Right here, if you're a right brain person, or right here, if you're a left brain person. Look, a, same sign, b, times a squared, opposite sign, a times b, always plus b squared. It's just whatever you can remember better, words versus symbols. Your choice. Questions? This is new. We didn't do this in 098. So this is the first thing that we've come to that y'all didn't do in 098. Okay? Try it. Now we've only talked about two processes, the difference of two squares and the sum and difference of two cubes. But listen, when I ask you to factor, what's the first thing you always look for? Greatest common factor. Don't forget that. Alright, so on the first one, remember I told you anytime you factor, look for something in common first. Well, in the first one, we can divide a 3x out. So if I divide here by 3x, that's going to give me 4x squared. If I divide here by 3x, that's going to give me a negative 9y squared. Don't stop, because that's a pattern. That is the difference of two squares. So we're going to bring our 3x down. And we're going to open up two sets of parentheses, plus in one, minus in the other. Square root of 4x squared is going to be 2x. And square root of 9y squared is going to be 3y. And a lot of you wanted to keep going. Don't multiply it back out, because if you multiply it back out, you're going to get what you started with, and then you just have a vicious cycle going on. So stop. One clue is we don't have any exponents. If you don't have exponents, you can't factor. Okay? Unless you want to factor out something in common, but there's nothing in common. So, all right, on the right, I have the difference of two perfect cubes. So the first thing I want to do is I want to take the cube root of x to the third, which is x, use the same sign, and take the cube root of 27, which is 3. Once you've done that, once you've taken the cube root, forget about that original problem. Don't go back to the x to the third minus 27. Leave it be. Okay? So we're going to take x, and we're going to square it. And then we're going to use the opposite sign. And then we're going to multiply x times 3 and get 3x. Always plus, take 3 squared, and get done. When you factor the sum and difference of two cubes, it will not factor again. Both groups are prime. So you're done. All right, so let's talk about trinomials. Now remember, when we talk about trinomials, you have two options. Either one, your leading coefficient, the first number you come to, your squared term, is 1, or your leading coefficient is not 1. And you factor these differently, okay? As long as your leading coefficient is 1, it's fairly easy. It's not so bad, okay? So what you're going to do, of course, look for anything in common first and take that out. If you don't have anything in common, or even if you do have anything in common, your next step, open up two sets of parentheses and decide on your signs. Now I'm going to give you a little chart that will help you find your signs in all of the trinomials. Okay? So the little chart goes something like this. If in your problem you have a plus and a plus, in your answer you should also have a plus and a plus. If in your problem you have a minus and a plus, In your answer, you have a minus and a minus. If in your problem, you have a plus and a minus. In your answer, you're going to have a plus and a minus. If in your problem, you have a minus and a minus. In your answer, you have a plus and a minus. Okay, so let's put this into layman terms. Watch. If you don't want to memorize the chart, remember this. If in your problem the second sign is positive, then in your answer the two signs have to match each other and your first sign. So if the second sign is positive, your answer is going to have matching signs, and they're going to match the first sign. However, if in your problem the second sign is negative, irregardless of the first sign, your answer signs are going to be different. Okay? Positive second sign, same signs. Negative second sign, different signs. Okay? Alright, so we decide on our signs. The next thing we're going to do is we're going to take the square root of our squared term. So if you have something like x squared, square root of its x. That goes in the front two spots. And then step number 4 is probably the hardest one of this whole entire process. You have to think, what can I multiply together to get the last number, but add together to get the middle number? So watch this. If I have something like x squared plus 5x plus 6. Okay? You have a trinomial, yes. Leading coefficient is 1, yes. How do I know the leading coefficient is 1? There's not a number in front of the x squared term. It's understood to be 1. Okay? So you're going to open up two sets of parentheses. What are the signs going to be? Plus and plus. The second sign's positive, which tells me the two signs in my problem have to match, and they're going to match that first sign. So plus and plus. Step number 3, take the square root of your first term. Square root of x squared is x. Okay, so now, let's think. What can you multiply together to get 6? 2 and 3. What else? 1 and 6. Okay? So you have two pairs that you can multiply together to get 6. Either 2 and 3 or 1 and 6. Only one pair will add up to 5. Which one is it? And that's your answer. So when you start doing these, you have to understand that last term could have a whole bunch of paired up factors, but only one pair. I call them the magic numbers because only one pair will work. Okay? And you have to get the right pair. You got it? To factor a trinomial with a leading coefficient is 1. Open up two sets of parentheses, decide on your signs. Take the square root of the first term, split it up, and then think, what can I multiply together to get the last term, but add together to get the middle term? It's a process you have to memorize. Try it.
Bring it on.
So on this one, what we're going to have is, again, in all three of these, please look for a common factor. There's not in any of these, but just make sure you look for that. All right, so we're going to open up two sets of parentheses. The second sign's positive, so the two signs have to match each other and that first sign. I'm going to split x squared into x times x, and then I have to think, what can I multiply together to get 12, but add together to get 8? So list the factors. We have 1 and 12, 2 and 6, 3 and 4. I have 3 different pairs, but only one pair gives me 8. So you have 2 and 6. Okay, let's go over here. Open up two sets of parentheses. The signs are going to be negative and negative. Why? Because that second sign is positive, which tells me the two signs have to match each other and that first sign. Split the x squared into x and x, and then think, what can you multiply together to get 24, but add together to get negative 10. So here we have 1 and 24, 2 and 12, and of course it's negative and negative. 3 and 8, 4 and 6. So you have 4 pairs, but only one pair gives you negative 10. So you get 4 and 6. Okay? Last one. This time the second sign's negative, which means the two signs in the parentheses are going to be different. Split your x squared into x times x and think, what can you multiply together to get negative 30, but add together to get positive 10, or positive 7. And I'm going to go straight to here. The possibilities you know are 10 and 3, because you can finagle 10 and 3 to get 7. So you have positive 10 and negative 3, or negative 10 and positive 3. And it does, that's what I was saying a while ago, it does matter about the signs. Because the second set is going to give me negative 7. And I don't need a negative 7, I need a positive 7. So it has to be this pair. So the 10 has to be positive and the 3 has to be negative. You don't have a choice. Okay? Questions? Yes.
Like on the first two, does it matter which side you put 6 or 4?
Nope. The question was, does it matter where you put the 6 and the 2 or the 6 and the 4? And the answer is no. It does not matter. As long as the signs are correct.